How's it going? My name's Dim, and in this episode I'll be taking our file storage web app BigBox and storing all information about our files in an SQL database. Expanding on our beautiful diagram here, we can see that our server is now going to be interacting with the PostgreSQL database whenever a user uploads or requests a file. That's simple enough, right? Let's jump into it. I'll be using two very useful tools in this episode, Docker and then ORM. In case you're not familiar with Docker, it's a platform that makes use of Docker containers to host small operating system instances that typically run one piece of software. If you're not familiar with what an ORM is, I'll come back to that in a second. The benefit of using Docker to install Postgres over manually installing Postgres on my system is that it is easy to reproduce on any system. As long as you have Docker installed and run the commands that you see on screen, it doesn't matter whether you're on Mac, Windows, or Linux. You will have a Docker server running on the same ports as I do. Now, after executing the docker run command with the Postgres image, you can see Docker fetching the image and its dependencies. Heading over to the Docker desktop application, we can see that our image exited with status code 1. Inspecting a bit further, it seems like we need to either set a root password or use another variable to bypass it entirely. I decided to go with the first option and add -e postgres_password equals epic, which adds an environment variable to the system called postgres_password. I also removed the -d parameter, which is supposed to detach the process, because I want to see the Docker process running in my terminal. The final command is up on screen, and you should be able to run it yourself to get a Postgres server up and running. Now that we have our database ready to go, let's connect it from our backend server. Here, I decided to go with a package called Go-PG. It is that ORM thing that I was talking about earlier. All an ORM does is it takes your data structures in your program and converts them to tables in the database that you're using. It comes with methods that allow you to structure SQL queries without actually writing any SQL code, resulting in what I personally consider much cleaner and much more readable code. Here we go get the package and copy some of the example code from the README. The first piece of code creates a connection to the Postgres database. We modify it by adding a password parameter, including that password that we started the Docker container with. Here, I also make the DB variable global. In hindsight, it wasn't really necessary, but it's up to you if you'd like to do the same. The second piece of code I copy from the README creates tables in the database. The great thing about using an ORM like GoPG is that all the fields and names in the struct are automatically converted to the SQL statement shown on screen. Furthermore, some fields like ID are automatically made primary keys based on their name. We modify the code we copied from the README to just create a table for the file struct because that is all we have at the moment. We also change the return error to a panic because if the connection or table creation fails, we obviously can't run the server. Something you'll notice here is that temp true is passed to the create table options. What this option does is it enables a feature within Postgres that drops the table whenever the connection that created that table is dropped. In effect, this means that when we run our program, a table is created, and when we quit out of our program, that table is dropped. This is quite useful in testing as it lets us create new tables each time the app is restarted, but as you'll see later, we actually end up disabling this option. Now that we've created the table we need, heading back to our post request, we'll insert the file data into the database using db.model_f.insert. The equivalent SQL statement is shown on screen. The insert method returns two values, but we don't really care about the first one, just the error. Now we should be inserting each file every time a user uploads. So let's go to our get method and retrieve that file from the database. To do this, we will create a struct with the data that we are going to query with. Since we have the file ID and only an ID is needed to retrieve the file, we will instantiate the file struct with the ID field set to the URL ID parameter. Here we're just modifying the code to handle there not being an entry with that ID in the database. Now let's make the SQL query using GoPG. To do that, we will call db.model on the file struct we just created. We are passing this struct's pointer so that GoPG can update its fields. If we don't include that ampersand right there, the struct will be copied and our values will remain unchanged. This is very important. Here it turns out that select only returns the error and nothing else, so we update our code accordingly. Here I seem to have some kind of issue importing GoPG, so I just directly copy the import paths from the README. Now that our server is running, let's try it out. Wow, it works first try. Let me restart the server just to make sure our database persists. Wait, we got a 404. What happened? Oh, we still have that temp option set to true, so our database got deleted when we restarted the server. Let's just get rid of that and try again. And an error. That's right, we are attempting to create a table that already exists. Let's just set if not exists to true. All this does is it attempts to create the table only if it does not already exist. Alrighty then. Everything seems to be in order, but wait, there was a mistake I made that I did not realize while recording. Did you catch it? When I wrote that line where I called select, I was under the assumption that the ORM would structure the statement like this because the ID is a primary key and I created the struct with ID set. However, the statement actually ended up looking like this. The reason it seemed to work is because we only had one file in our database, so that row was being returned and all was well. But as soon as we have multiple files in our database, this statement won't work because it'll return all the rows in the database, so it is not clear which one we actually wanted. To fix this, we just have to add a call to where_pk before the select call, and that results in us getting a query like this one. Anyway, that's it for now. I hope you have a good foundational understanding of how ORMs work and that you see the power of using a good ORM. I'll include a link in the description to the GoPG docs so that you can explore some more of the methods and syntax. In the next episode, we'll be adding the ability for users to authenticate with Google using Firebase, which will let them view the files they've uploaded and delete them. Anyway, thank you for watching, and until then, stay tuned and peace out.